All right, let's talk about something that might just be the single most important new standard in AI. It's called the Model Context Protocol, or MCP for short. And people are calling it the USB-C of AI. You know, that one universal connector that finally lets everything just work together. The promise here is huge to give our AIs hands and eyes. But here's the big question we're going to tackle. Is this thing a genuine revolution, or is it a massive security risk just waiting to happen?
So think about your favorite LLM right now. Could be Claude, ChatGPT, whatever. It's kind of stuck. It's this incredibly smart brain for sure, but it's trapped inside a digital box. It can't see your live data, it can't touch your apps. It's totally cut off from the real world. And if you want to give it those hands and eyes, connect it to something simple like a database or even your Google Drive, what do you have to do? Well, developers end up writing these huge mountains of custom, really fragile glue code. And let me tell you, it's a total mess, it's unreliable, and it just creates this absolute nightmare of tangled up code. We call it spaghetti code for a reason.
Yeah, this isn't just some small annoyance. It's a massive architectural headache. And in the industry, it has a name, the M by N integration crisis.
Okay, so here's what that actually means. Let's say you've got, I don't know, 10 different AI models, and you want them all to be able to talk to 10 different tools. Well, guess what? You're on the hook for creating and maintaining 10 times 10. That's 100 unique, custom integrations. It's insane. This just doesn't scale. It's wildly expensive. It's super fragile. And honestly, it's been the biggest thing holding back the development of really powerful AI agents. So how do we get out of this mess? This M by N chaos? What the industry really needed was a universal translator. You know, a single standard that any model could use to talk to any tool. And that's exactly where the Model Context Protocol, or MCP, comes in. The best way to think about MCP is like a common language. Instead of building all those one-off custom connections, that M times N nightmare, you just teach your M models and your N tools how to speak this one shared language, MCP. And just like that, you've reduced the problem from M times N down to M plus N. It's a huge difference, and it unlocks this massive ecosystem where all these tools can just talk to each other. Okay, let's break down how this actually works. It's a pretty elegant setup. First, you, the user, give a prompt. Easy enough. Now, step 2 is the key part. The LLM just reasons. It figures out which tool to use, but, and this is super important, it doesn't actually do anything itself. Then, step 3, the client takes that decision and sends a standardized request to the right MCP server. And finally, the server, say a Postgres server, is the one that actually does the work and sends the result back. See that separation? The brain, the LLM, is separate from the hands, the server. That creates a really important security boundary and makes the whole thing safer and easier to scale. So when an MCP server connects, it can offer up its powers in 3 main flavors. First, you've got tools. These are the action items, the verbs, things the model can actually do, like run_SQL query. Then you have resources. Think of these as read-only cheat sheets, like a database schema that just give the model some much-needed context. And finally, there are prompts. These are basically shortcuts that you, the user, control directly, like a slash command to /generate report. Okay, so a universal standard, a huge ecosystem of tools, a super clean architecture. This all sounds amazing, right? Like the perfect solution. But you know how it goes. With any shiny new tech, there's always a catch. And the criticisms leveled against MCP, well, they're pretty serious. Let's dive right into the biggest one, security. The major concern here is that MCP, in its race to make everything easy and convenient, might have accidentally opened up a whole new can of worms when it comes to vulnerabilities. So just imagine for a second, you have one MCP server, and it holds the keys to your Gmail, your Slack, and your company database. That thing becomes a massive target for token theft. But it gets even scarier. What if you get an email with malicious instructions hidden in tiny white text? That's called indirect prompt injection. Your AI sees it, gets tricked, and suddenly starts forwarding all your private files to some attacker. This is a classic security problem called the confused deputy. The AI has all the right permissions, but it's being tricked into using them for evil. And this quote from the tech company Cosign really hits the nail on the head. They point out that the whole MCP ecosystem depends on these third-party servers, and a lot of them are just open-source projects that someone cobbled together. I mean, are you really comfortable running some random, unvetted code that has the keys to your entire kingdom? It's a huge risk, to say the least.
Okay, so security is a huge concern, but it's not the only one. There's some really smart people making deep architectural critiques, too. They're asking, is MCP really this elegant new standard, or is it just a fancier, more complicated version of the same old glue code? And check out this other zinger from Cosign. They call MCP probabilistic glue. What does that mean? Well, a normal API call is deterministic. It does the exact same thing every single time. But when you route a task through an LLM, it's probabilistic. It's not guaranteed to behave the same way twice. You're basically replacing solid, predictable code with something that might just break when you need it the most. That's a scary thought.
So, to sum up these architectural problems, first, it can be really fragile. There's no standard for versioning yet, so some server could update and boom, your whole agent is broken without any warning. It can also make simple things way more complex than they need to be, adding extra steps and slowing things down. And my personal favorite, what happens when you rely on some cool open source server and the developer just disappears? Yep, now you're the one stuck maintaining it. Good luck with that.
All right, so we're left with this paradox, right? MCP is this brilliant idea on one hand and a potential nightmare on the other. So how do we make sense of it all? Well, the best way to look at it is through a lens that every engineer knows and loves, the classic buy versus build decision. This really lays it all out. Think of using MCP as the buy option. It's fast, it's easy, and it's perfect for the common 80% of things you're gonna wanna do. You get instant access to this huge ecosystem of tools, which is amazing for getting a prototype up and running quickly. But then there's the build option, using a native SDK directly. This is for that critical 20% of your project, the mission-critical stuff where you absolutely need the best performance, the tightest security, and total control. So, what's the verdict? The big takeaway here is that MCP is not a silver bullet. It's not going to solve every single problem you have. But, and this is a big but, it's still a super powerful and frankly necessary standard that fixes a huge problem for the vast majority of cases. The real trick is knowing when to use it, and when you need to roll up your sleeves and go for that more direct, custom-built approach. And the good news here is that MCP isn't just sitting still. The folks behind it are actively working to fix these problems. If you look at the roadmap, you can see they're adding things like support for long-running tasks, making it more scalable for big companies, and even creating official extensions. All of this is aimed at making the whole thing more robust, more secure, and ready for the big time. And that brings us to the big final question. What is MCP really? Is it just a temporary bridge, a clever hack we're using in these early wild days of AI? Or is it the permanent foundation? Is it the real USB-C of AI that the entire future of the interconnected AI economy is going to be built on? Honestly, no one knows the answer yet, but figuring it out is going to define how all of us interact with technology for years to come.